In this video, we'll discuss special right triangles. They're a useful way to develop some shortcuts to maybe get us out of the Pythagorean theorem, but it's also a great way to start establishing trigonometry as a relationship between triangles' angles and their sides. Let's start with one of the easier special cases of right triangles. Let's start with the 3, 4, 5 right triangle. So the 3, 4, 5 would be referring to the sides of a right triangle, meaning that if I have a right triangle with legs 3 and 4, well, if I use Pythagorean theorem, I can say 3 squared plus 4 squared has to equal, for now, let's call it c squared. Okay? If I simplify the left side a little bit, I get 9 plus 16 has to equal c squared, which means that c squared has to equal 25, meaning c has to be 5. So this would mean c is 5. Now the cool thing about this is that if I multiply all these by 2, meaning that this side would then become 6, this side would then become 8, and this side would then become 10. This relationship still holds true. This is a similar figure. If you can notice this trend, you can use this to your advantage for other 3, 4, 5 cases, even if they're not necessarily 3, 4, and 5. They could be 6, 8, 10, as well as any other multiples of 3, 4, and 5. The next case we'll look at will be a 45, 45, 90 triangle. Now this refers to the angles of the triangle. So, in a right triangle, for sure we have our 90-degree angle, but let's look at the case of both of these being 45 degrees, meaning they're both congruent. Okay, in this case, we have side lengths, let's call them 1 and 1 for the base case. Okay, if I wanted to know what the hypotenuse was, for now let's call it x, I would take 1 squared plus 1 squared, following Pythagorean theorem, is equal to x squared. If I did that, then I'm going to get 2 on the left side equals x squared, meaning x has to equal the square root of 2. This is a special case, and it'll hold true. Let's say I multiply this side by 3, in which case this side has to be the same because they are congruent. It's an isosceles right triangle, meaning that I would do the same thing here to the hypotenuse, multiply it by 3. So 3 times the square root of 2 would be the length of my hypotenuse. It's a nice shortcut. It's useful for a lot of squares, because if you cut the diagonal of a square, you always get a 45, 45, 90 triangle. And it's just a nice shortcut, and it'll help build the bridge for trigonometry. The last case we'll talk about in this video will be a 30, 60, 90 right triangle. This also refers to the angles of a right triangle, meaning that I have my 90-degree angle, and then one of the angles is 30 degrees, and then by extension, the last one must be 60 degrees. Okay, in this case, the angle that is across from the 30-degree angle right here, let's call it 1 for now. If I look at this side, the hypotenuse is going to be double whatever that is. And then the last one will be square root of 3 times whatever the smallest side is. In this case it's 1, but we could easily replace it with any number. For now I'll use an L. So if I know one side, I can solve for the other two, and we'll see that in a couple of the examples. Before we get to the examples, this is just a summary of what we've talked about thus far. We have 3, 4, 5 triangles, meaning that if I have a right triangle where I can multiply them all by one number, and I still have the ratio of 3 to 4 to 5 with my sides, I can use that to my advantage to solve for the other sides if need be. With the 45, 45, 90, if I know one of the smaller sides, all I have to do is take it times the square root of 2 to find the hypotenuse, and they would be the same. If I know the hypotenuse, I would divide by square root of 2, and that would get me back to my smaller sides. And then looking at the 30, 60, 90, if I know one of the sides, say I know L, I know the hypotenuse is double whatever L is, L being the side across from the 30-degree angle. And then I know that the side across from the 60-degree angle, the middle length, is L times the square root of 3. Now if I know one of the others, I can follow a similar sort of pattern. If I know the hypotenuse, I can divide it by 2 to get to the 30-degree angle. Or alternatively, I can use similar line of thinking if I know L times the square root of 3. Now that we've talked about all the special cases of right triangles, let's actually put them into practice. Let's start with the 3, 4, 5 example. If I wanted to solve for x, which I know this is a right triangle, we could use Pythagorean theorem, but this would allow me a shortcut if I'm using 3, 4, 5. I could note that 15 is 3 times 5. And I could also note that 20 is 4 times 5. Therefore, this must be a 3, 4, 5 triangle. And I know that x has to be 5 times 5, which would mean that x equals 25. Now that just gives me a shortcut. You can use Pythagorean theorem and you would just as easily get to 25, but this allows us kind of a jump to get there a little quicker. Okay, let's look at a case of a 45, 45, 90 in practice. So in this case, I only know one side. I can't use Pythagorean theorem. This is where these two special cases kind of shine. I know that these angles are congruent right here. Okay, if I know one length is 5, well then I know the other has to be 5. It is an isosceles right triangle because the base angles are congruent. Okay, and then that would just leave me y. Now if I follow my formula, in this case L is 5. So to find y, I know I have to take L times the square root of 2. So this would just be 5 times the square root of 2. And this is an exact answer. You can leave it like this, or you can run to a calculator, punch it in, and you'll get an approximate decimal value. All right, let's look at our last example, which being the 30, 60, 90 case. Now again, I only know the one side. In this case, it's okay. I would not be able to use Pythagorean theorem, but because of this special case, we'll be able to figure out the other two sides. If I consider our generalized form of a 30, 60, 90, let's say this angle is the 30 right here. Okay, across from the 30, we call that L. The hypotenuse we know to be double whatever L is, and we know that the last side would have to be L times the square root of 3. Okay, we can use that to our advantage. Here's L. We know L is 3, which would mean that x has to be 2 times L, or 2 times 3, which is 6. That wasn't too bad. So x is 6. There's one answer. And then I have to look at y. If I'm looking at y, I know that this has to be L times the square root of 3, which means that I take 3 times the square root of 3, since L is 3. Then y has to equal 3 square roots of 3. Now again, this is an exact answer. It's totally fine to leave it like this. This gives you the exact value of the thing. If you go to a calculator, it'll give you an approximate value, it'll give you a decimal, but you have to round off somewhere since these square roots are irrational numbers. Hope this video is helpful. Good luck.